Okay, so we're going to start reviewing for test number 3-1, which is on Friday, February 1st. Extra help is going to be on Thursday after school. This is mainly on the big topic that will be on it is logarithms, which is throughout this entire review sheet. So for the first and second question, it says solve the equations with fractional exponents. I understand that there are no fractional exponents in it. However, there are radicals, and radicals really just are fractional exponents. For example, if I have 27 to the 2/3 power, that's really the cube root of 27 squared, which ends up giving you 9 as an answer. Okay, so for the first one, you want to first isolate the radical. So for number 1, you're going to subtract the 2x over. So this is going to be the square root of x plus 2 equals 2x plus 3 after I subtracted that 2x over. Now to get rid of the square root, because the square root is really an exponent of 1 over 2, to get rid of that, you're going to square both sides. When you square the left, it's easy. You get x plus 2. On the right, though, you have to remember to double distribute. You have to do 2x plus 3 times 2x plus 3, which gives you 4x squared plus 12x plus 9. It's a quadratic equation, so I set it equal to 0. So this is 0 equals 4x squared plus 11x plus 7. Now I can factor this. It is factorable, so I'm just going to go straight through it. You are probably going to do 4 times 7 gives me 28. What two numbers multiply to be 28 and add to be 11, so on and so forth. Once you finish that, you should get 4x plus 7 and x plus 1, which gives me the two possible answers of x equals negative 7 over 4 and x equals negative 1. You have to plug everything in once you're done with this, okay, especially with radicals. When I plug in negative 7 over 4, it does not work. So my only answer here is x equals negative 1. For number 2, this is really 3 times x plus 2 raised to the 2/3 power plus 9 equals 21. Okay, again, radicals really just are fractional exponents. So I have to isolate whatever is being raised to that exponent. So I have to subtract 9 and then divide by 3. So 21 minus 9 gives me 12. And then 12 divided by this 3 over here gives me a 4. Now I'm going to get rid of the fractional exponent, I'm going to raise both sides to the reciprocal power. So it was 2 over 3, so I'm going to raise it to the 3 over 2. Both sides raised to the 3 over 2. So on the left, this cancels. I have x plus 2 equals. The right side, you can type right into your calculator, although I know some of you are getting good at doing these in your head. This is asking me for the square root of 4 to the 3rd. The square root of 4 is 2. 2 to the 3rd is 8. If you type it in your calculator, it just gives you 8. And then you subtract the 2, you get x equals 6. Plug 6 back into your original equation. You end up that it works out, and that's your answer. Okay? Numbers 3 through 8 are pretty much just asking if you understand what logs are. Okay? This is how we introduce them. So one day we spent on converting them back and forth. So for example, number 3, again, logarithms are the inverse of exponential equations. So it helps you bring down the exponent. So here, 3 equals log, the base stays the base of 512. For number 4, 6x equals, now you could write log base e of 214, or because it's log base e, you have the ln of 214. Okay, that's probably how you would see it if that were multiple choice. 5 and 6, you're doing the same thing, you're just going the other way. So in class I gave you a phrase that phrase was start at the base and run the race. So for number 5, you start at the base, which is 3, and then you go around the other side of the equal sign, that's your exponent, equals 102. Okay? It matches what we just did a second ago with 3 and 4, it's just going the reverse way. So number 6, there is no base written here. However, it's a natural log. Natural logs have a base of e, so you don't have to write the e. So this is really e to the 14th equals 2x plus 1. Number 7 and 8 are for evaluating. Okay, so you could type these into your calculator, but I do want to make sure you understand what this is asking you. Number 7, that is asking me 6 to what power is 216? Okay, so some of you should be able to definitely do that in your head. 6 to what power is 216? That's going to be 3. If you type it into your calculator, the way that you can change the base, if you press alpha, window, number 5, it lets you manipulate the base of the log instead of just pressing the normal log that's on the left side of 7 on your calculator. Okay. Number 8, there's no base here, but it's a common log. It has a base of 10. So this is saying 10 to what power is 1 over 10,000. So first of all, because it's 1 over 10,000, it's going to be a negative answer. Okay? And then 10 to what power can give me 10,000? That gives me 4. So if you type that into your calculator, you end up getting negative 4. Numbers 9 and 10, we are using the log properties. We spent 2 days doing this. Okay? If you have multiplication, that can be expanded with addition. And if you have division, that can be expanded using subtraction. So for example, number 9, this can be rewritten as log of x to the 7th plus log square root of y minus log of z. And now the only thing left to do is if you have any exponents, those exponents go out to the front. This is the property that we've been dealing with the most. So log of x to the 7th, that can be rewritten as 7 log x. Log square root of y. Square root is really an exponent of 1/2. So this is plus 1/2 log y. And then minus log z is boring. There's nothing for you to do over there. Okay, and that's my answer for number 9. For number 10, same idea. So this is log cube root of a plus log cube root of b. Both a and b are being multiplied inside of a cube root, so they're both in a cube root when you separate. And then minus log of c to the 4th. Now the only thing to do is to bring those exponents out front. So if you have a cubed root, the cubed root really has an exponent of 1 over 3. So this is 1 over 3 log of a plus 1 over 3 log of b minus 4 log of c. Number 11 and 12 are doing the same thing, just going opposite. So now we're going to condense. We're going to make the log smaller. Okay, so how I always start this, I always take care of the exponents first, and then I put everything together with the division and multiplication. So for number 11, this is really log square root of 49, which the square root of 49 is really 7. So I'm going to write this as log 7 plus log of x to the 4th minus log of y squared. So now when I put this together, I push it together, the addition and subtraction, my final answer is going to be log of 7 times x to the 4th divided by y squared as my final answer for number 11. For number 12, this one has a lot going on actually. For number 12, this is log of x to the 5th plus log of 4x squared minus log of 2x to the 3rd. So now, if I want to take care of these exponents, I can actually distribute everything. So this is log of x to the 5th plus log. Power to power, 4 squared is 16, x squared is x squared, minus the log, again, same thing, power to power. 2 to the 3rd is 8, x to the 3rd is x to the 3rd. So now, when I combine the addition and subtraction, I have log of x to the 5th times 16x squared divided by 8x to the 3rd. And now I have those properties that we did on the first day. So, my final answer here, 16 divided by 8 gives me a 2. And then x to the 5th times x squared is x to the 7th. And x to the 7th divided by x to the 3rd is x to the 4th. That one was a little tricky. (13 through 15). We've done a lot more practice, especially with word problems, with answering these. Okay. For number 13, these are exponential equations, and here you can't get a common base for any of these, so you are going to need logarithms. So for number 13, you want to isolate whatever the base is. So in this case, it's already done. So what I'm going to do is take the log of both sides. When I do that, the 3x can come out front. So this is 3x log of 1.25 equals the log of 10. Log of 10 is really just 1, so if you want to write 1, you're totally fine with doing that. Now I divide both sides by the log of 1.25, and I get 3x equals 10.31885. Do not lose that number in your calculator, right? You're not going to double round, so you divide both sides by 3. You get x equals 3.440. It wants it rounded to the nearest thousandth. That's 3 decimal places. Number 14. Again, isolate the base and the exponent, so you have to divide both sides by 4 first. So now this is 5 raised to the 6x minus 1 equals 33 divided by 4 gave me 8.25. And now I can bring the logarithms into it. So this is 6x minus 1 times the log of 5 equals the log of 8.25. Divide both sides by the log of 5. I get 6x minus 1 is equal to 1.31114. I add the 1, add the 1 over. Keep that number in your calculator still. And then I divide that number by 6, and now I can round. So my final answer is going to be 0.385. Round into the nearest thousandth still. Okay. Number 15. Same idea, but now our base is an e. So now instead of taking the log, you really should take the natural log. So first I'm going to add 4. Then I divide both sides by 5, and now I have e raised to the 2x plus 1 equals 12.8. Now what happens when I take the natural log of both sides? This is 2x plus 1 times the natural log of e. The natural log of e is just 1, so it cancels out, equals the natural log of 12.8. So in my calculator, I do the natural log of 12.8, and then I'm going to subtract 1. So I get 2x is equal to 1.54944. Keep that number, and then divide by 2. In my final answer, I get x equals 0.775 as my final answer. If for number 15 you did not take the natural log, you took the common log, as long as you do it the same way and you do it correctly, you still get the correct answer. Okay, so even if you take the log of e and then you divide by the log of e and everything, you still get the right answer. Okay, so if you don't like the natural log, that's okay. It's really not that big of a deal. As you move into higher level math, though, they do use the common log. They do use the natural log, rather, more than the common log. Okay, that's more calc stuff. And then numbers 16 and 17, it wants us to graph it. Okay, so I'm going to take a second now to pause it and write down my table. Okay, so you should have a table, and then your graph ends up looking something like this. You never touch -5 for your y value. Okay, it keeps getting closer and closer. So for this, my domain, my x values, I keep going to the left, keep going to the right. My domain is all real numbers. My range, though, my y values, they don't go all the way down. My smallest possible y value is as close as I can get to -5 without hitting it. So with the parenthesis, it's -5, and then it goes up until infinity. For the asymptote, this is a horizontal asymptote. Horizontal asymptotes are y equals, and then that y value is -5 that I keep getting really, really close to without touching. The y-intercept is 0, -4. And then this function is increasing. This shows exponential growth. And the way I know, too, from my equation is because the base is a 3. The base is a 3. If the base is larger than 1, it is increasing. For number 17, again, I'm going to put you on pause, and I'm going to write down a table and then graph it, and you can compare your graph to mine. Okay, for number 17, my graph kind of looks like that. You can see your y values as you move up, as you go to the right. For your domain, your y values are getting closer and closer and closer to -1. Okay, so for this function, my domain is also all real numbers. My range, the smallest possible y value is as close as I can get without touching -1 up until infinity, which means that the asymptote is y equals -1. The y-intercept here, where it crosses the y-axis, is at 0, 1. And then this is decreasing the entire time, which means that this is going to be an example of exponential decay, which makes sense because my base is 1/3, which is less than 1. Okay, so now we're going to move right into word problems. So we have 5 word problems. For the first one, you should be using the half-life formula. Half-life formula, you need to memorize all of these. Half-life formula is A equals P times 1/2, or 0.5 raised to the T divided by H. So I go through and I read this, and my first question, algebraically determine its half-life. So I'm solving for H, which means I plug something in for everything else, right? So A is how much I end with. So in this case, I end with 11 grams. I start off with 16 grams, that's P, 1/2. The amount of time that's passed is T. So in this case, it's been 10 years divided by H. So first I'm going to divide both sides by 16. I get 0.6875 equals 1/2 raised to the T divided by H. I throw logs in. So this is log of 0.6875 equals T over H. It's the whole point in using logs. Log of 1/2. Divide both sides by the log of 1/2. I get 0.54056 equals 10 divided by H. I'm going to come up here. I cross multiply, and I get 0.54056H equals 10. You should keep that number in your calculator. Do not get rid of that number. And then lastly, I divide by that number, so I get H is equal to, and you should get 18.5 years. 18.5 years is the half-life. And that answers the first question. The second question, then algebraically determine how many years it will take to only have 3.8 grams left. So how many years is my T value? So I have to plug something in for everything else. So now my A value is going to be 3.8. So my equation now is 3.8 is equal to, you're still starting out with 16, still have half-life. You're solving for T, and then the half-life you just found is 18.5 years. Okay, here you can use the rounded number because you just used that to answer a question. So I divide both sides by 16. I get 0.2375 equals 1/2 raised to the T over 18.5. I need logs to pull down that exponent, so this is now the log of 0.2375 equals T over 18.5 times the log of 0.5, or 1/2 rather. Same thing though. Divide both sides by the log of 1/2. So now I get 2.07400 equals T over 18.5. And then I cross multiply. So my final answer here ends up being T is equal to 38.37, and that is in years as well. For number 19, okay, that's it for half-life. For number 19, Natalie deposits $15,000 into an account paying 4.5% annually, compounded semi-annually. So this is the compound interest formula that you need to memorize. That is A equals P times 1 plus R over N raised to the N times T. The question is, I think it's only one, algebraically determine how many years, rounded to the nearest tenth. So how many years, that's going to be your T variable, which means you have to plug something in for everything else. So A is how much you're ending up with. So we want there to be 24,500 in the account. She started out at 15. Then you have 1 plus the rate, you got to move the decimal over, so 0.045 divided by N. N is how many times it's being compounded per year. If something happens semi-annually, it's happening twice a year, raised to the 2T. And then I solve this. So first I divide both sides by 15,000. I get 1.63 repeating equals this number. I'm going to clean this up. This is really 1.0225. Okay, equals 1.0225 raised to the 2t power. So now I need to pull logarithms into it because I have the base isolated. So this is log of 1.63 equals 2t log of 1.0225. I divide both sides by the log of 1.0225, and now I get 2t is equal to 22.04986. To get t by itself, divide both sides by 2, and I can round to the nearest thousandth. I get 11.025, and that is in years. And then last one, well, on this slide at least, number 20. Stephanie invests $550, compounded continuously. The second that you see continuously is PERT. Continuously is PERT. So how much money, there's two questions here. First, how much money will be in the account in 6 years? That's an easier question, no logs required because you're solving for A. So A equals 550, that's how much you're starting out with. E, the rate is 0.015, and then T is 6 years. So here, there's nothing really for you to do other than plug in your calculator. This is money, so you should be rounding 2 decimals. You get $601.80. The second question, a little bit more meat to it, algebraically determine how long it will take. So how long is T? And we want to have 1625 in the account. So 1625 equals 550. E raised to 0.015 T. Divide both sides by 550. I get 2.95454. Keep that decimal. equals e to the 0.015t. Because the base is e, you don't have to, but because the base is e, you might want to take the natural log of both sides. So here I have the ln of 2.95454 equals 0.015t ln of e, which the ln of e is just 1, so I don't really need to write that. It cancels out. So the only thing to do here is divide both sides by this 0.015 number. And I get t is equal to 72.2, and this is in years. Number 21, the value of a car depreciates at a rate that is not continuously, which means I'm going to use exponential decay formula, 1 minus r raised to the power of t. We want to know how many years, so t, it will take for the car to be worth half its original price. It originally was worth $30,000, so now it is worth we want it to be worth $15,000. Equals 30,000. 1 minus, the rate is 0.175 raised to the power of t. Divide both sides by 30,000, you get 0.5 equals, this 1 minus number turns into 0.825 raised to the t. Log of 0.5 equals t log of 0.825. I divide both sides by the log of 0.825, and to the nearest hundredth, I get t is equal to 3.60 years. Okay, and then final question. During the years 2000 to 2020, the mosquito population is given. A is the population in thousands, t is time is year. So first it wants me to state whether this is exponential growth or decay. So this is going to be exponential growth because the base here, this 1.02 number, is larger than 1. If the base is larger than 1, then that is exponential growth. Okay? So the way I can figure out, because now it wants me to figure out what the rate of growth or decay is. You might be able to see that it's 0.02 or 2%. If you can't figure that out, though, the way you figure that out is that 1 minus r is equal to 1.02. So when you subtract 1 plus r, because it's growth, I'm sorry. So when you subtract over the 1, you get r is equal to 0.02, which is 2%. Here it doesn't say the percentage or percent rounded to the nearest whatever, so you could say 0.02. Okay? And now the last question. To the nearest whole, predict the population of mosquitoes in the year 2014. Okay, so this really should say t is the time in years. T is years since 2000. Okay, but you're going to plug in 14 for t. So we're solving for A equals this equation, 1.02 raised to the 14th. So I end up getting this number here, right? However, this says is the population is in thousands. So this here is in thousands, and it wants it rounded to the nearest whole. So what I would do is move my decimal over 3 times, or multiply the number by 1,000. So this is really 2,111,166, and this rounds to stay the 6. So this is the correct answer in mosquitoes. Okay, that's kind of like that last question that was on your midterm with the tidal wave being in hundreds of miles per hour. Okay, any questions, come to Extra Help. I hope to see you there. Have a good night.